Okay, so let's have a look at fission. Now, this has come as a request from Michael in Year 11. Fission. What is fission? Well, we start off with a large nuclide. Okay, in a standard nuclear power station, this would be uranium. Okay, then we fire a neutron at it. Okay, so neutron. What does this do? Well, this breaks this large nuclide apart. And what's released, we've got some energy, okay, E. We've got 3 more neutrons that are released. And I'll just put a little N next to them so we know they're neutrons. And we've got what we call a daughter nucleus. So this uranium doesn't just disappear and become energy and neutrons, there's also something else as a decay. Now, what we're worried about, or what we're focusing on, is these neutrons. So what happens to this neutron? Well, it hits, again, if we're talking about a nuclear power station, it hits another uranium nuclide. What happens to this one? It breaks apart. Okay, we get the same, we get our neutrons, we get energy, and we get a daughter nuclide. Where does this energy come from, I hear you ask? Well, Einstein's famous equation, E equals mc squared. This says that energy is equal to the amount of mass times c squared. C is the speed of light, which is 3 times 10 to the 8 meters per second. Okay, now, what we find is that from the uranium, when it's gone into being these different parts and your daughter nuclide, it's lost some mass. And that's a strange thing, really. If you were to put this on a set of scales and weigh that, you would find it was 1 mass. If you put all of this stuff that's come out of it, you would find it's a slightly smaller mass. Now, that amount of mass is converted into energy, which is where we get this equation from. So the amount of mass times by the speed of light squared equals the energy produced. Okay, now, perfect definition for this, for a couple of marks on an exam question. Fission is when larger nuclides break apart to form smaller ones. And in this process, energy, E, is released. Now, what we've got to be careful of with fission is that if we let this process continue, so this one breaks apart, releases these neutrons go and hit another nuclide, we end up with what we call a chain reaction. So if this continues, and I'll write this here, chain reaction. Okay, now we've got to be careful because if we have a chain reaction, what's happening is more and more energy is being released. So how do we stop this? Well, in a nuclear power station, if we've got our neutrons being fired, we have what we call a control rod. Okay, now this control rod stops these neutrons from hitting another nuclide, or stops this one from hitting another one. And in this way, we control the reactions that are taking place. If we need more energy, we move this out of the way, we let more neutrons hit other nuclides. If we need less, we move it up, we block their path. Okay. Is radioactive waste produced in this process? Yes, it is. So, produces radioactive waste. And this is the main disadvantage of fission, as well as the fact that if we don't control it, or we have problems similar to Chernobyl in Ukraine, where they had a nuclear meltdown, massive explosion, and people still can't live there now. Okay? Hope that was helpful.